Hi, today in 7th grade, we will be conducting a volume lab on regular and irregular solids. After you receive your packet, refer back to Chapter 2.1 and 2.2 of your science book. That will help you answer some of these questions. You do need to know what a meniscus is, which is the level of volume at the bottom of the curve when you are measuring the volume of your liquid. After you refresh your memory on what a meniscus is in your book, you can write the definition right here. Next, refer to your book with the SI units. It will tell you what the basic unit for measuring liquid volume is. It is the liter, although in this experiment, we will be using milliliters and cubic centimeters. You can write that on these lines here. Next, what is the basic unit for measuring length in the metric system? It is simply the meter. And then, what do the smallest marks on your metric ruler represent? In your agenda, you do have a ruler. Refer to this. Here, it will tell you that the centimeter markings are the longer ones on your ruler. So right here where the numbers are. And each centimeter is divided into 10 milliliters, which are the shorter ones. The purpose of this experiment today is to determine the volume of regular and irregular solids based on what we have read in Chapter 2 of our book. Before you get started, you need to make sure that you have everything to conduct your experiment. So in the materials section of your lab report, make sure that you have your pencil. Make sure that you have a 100 ml beaker of available water. Make sure that you have 3 marbles. You will need a piece of scrap metal. This will serve as your irregular solid. You'll need a triple beam balance from the cabinets in the science room. That is this. You will also need a 1 ml pipette. See how this goes up to 1 ml. You will need your metric ruler for measuring regular solids, length times width times height. You'll need 100 ml graduated cylinder. And you'll need a 10 ml graduated cylinder. You will also need your note cards. This pack in particular, so that you can measure length times width times height. After you have everything that you need, make sure that you write it in your materials and your methods section. When you do your experiment, you may find that you've forgotten to add something in there. You can always go back and add it in later. Once you have everything that you need, we can get started. The first question says, how much liquid can your graduated cylinder measure? You need to decide what graduated cylinder you're going to use today, whether it's the 10 ml, the 25 ml, or the 100 ml graduated cylinder. There's the 10 ml, the 25 ml, or the 100 ml graduated cylinder. After you decide on that, write your answer on this line here. If you are using a beaker today, how much liquid can your beaker measure? A beaker is something that looks like this. There's a little bit of water in it already, but this one can go up to 200 mLs. We have some that are 100 or 50 mLs in the cabinet. You decide which one you may want to use today. Lastly, how much liquid can your pipette hold? We will only be using this one pipette, which can hold only 1 mL of liquid. Next, it says fill your pipette so that it shows it is half an ml full. So that you want to fill the water up into your pipette to halfway. Then slowly drip the water out of the pipette and count the drops. So go to your available beaker of water, grab an empty beaker, and count the drops that you have in half an ml, if a drop were to look like that. Then record that number here. If you multiply that number by 2, that will give you the total number of drops in 1 ml, or the total number of drops estimated in 1 mL from this pipette. The second part of the lab says fill your graduated cylinder to 10 mL of water. The first part is deciding that you want to use the 25 mL graduated cylinder. After you fill to 10 mL of water, which is here, go down to eye level and make sure that your meniscus is at 10 mL of water. Then carefully add drops from your pipette fill it to 0.5 mL and raise the level of water from 10 mL to 11 mL in your graduated cylinder. So starting from here, see how many drops it takes to get from 10 mL of water to 11 mL of water. It should be pretty close to the number that you wrote down in this line here. If it took you approximately 24 drops of water to fill 1 mL, to raise the volume 1 mL from 10 mL to 11 mL in your graduated cylinder, it should take you about 24 drops. Maybe you got something different. If it took you 50 drops, that's okay. If you had 25 drops in half an ml and you calculated by 2 to get 50 drops in 1 ml, and you found that it took you 50 drops to get from 10 mLs to 11 mLs, then write that number down. Make sure that you repeat your trial 3 times and get an average. The third part of your lab experiment asks you to calculate how many drops will it take you to reach 1 liter, or the equivalent of 1,000 milliliters. Show your calculations. Based on the number that you got here, let's use the average. You will have a different number than me, but you can do this calculation the same way. If in 1 milliliter of my pipette, I found that I have 24 drops, then how many drops will I have in 1,000 milliliters, which again is the same as 1 liter. We solve for x by doing a cross multiplication division problem, whereas 1,000 times 24 equals 24,000 divided by 1. So I had approximately 24,000 drops in 1 liter. Whatever average number you got, you put that number here. You substitute your number in place of mine. And you do 1,000 times your number, and that will give you the amount of drops that you should have in 1 liter. In parts 4, 5, and 6 of the lab report, we will be finding the volume of regular and irregular solids. In this first part, it says find the volume of the regular solid, which is the pack of note cards here. Using your ruler from your agenda, find what the length, width, and height would be for this pack of note cards. Remember that length times width times height equals volume. And we're going to write our answer with the units of cubic centimeters. Number 5 says find the volume of the irregular solid now. We are using the scrap metal. Decide which graduated cylinder you'd like to use. Instead of a beaker, I want to use this 100 ml graduated cylinder. Decide how high you want to fill your water. If you decide to fill your graduated cylinder to 40 mLs, make sure that you are at eye level and that can see the meniscus at 40 mLs. Then write down the volume of liquid in your beaker without the metal. You may decide on 50 mLs, 35 mLs, 60 mLs. That's up to you. Next, add the metal to the beaker. Drop it right inside. You will see how the volume of water rises. Then record that volume. Find the difference from the new volume minus original volume and it will give you a number. That difference is the volume of your irregular scrap metal. In the last part, step 6, it says fill your graduated cylinder to 25 mLs of water. This is where you will need your marbles. Drop all 3 marbles inside the water and find the new volume. Much like we found here, find the displacement of the volume. That will be the volume of all 3 marbles. Take that number and divide it by 3 to find the volume for 1 marble. That number will give you an answer in centimeters cubed. For the last section, go to the cabinet and find your triple beam balance. Refer to your worksheet and your book in Chapter 2 and label the parts listed and asked for the triple beam balance identification.